Today, I'm going to introduce a Qt Learning Kit. It focuses on the popular open-source platform Arduino. You can learn the knowledge of the Arduino servo and ultrasonic ranging module by applying this kit. Meanwhile, you will be able to assemble a pretty cool bi-robot, like this one I'm holding, by yourself. It's a new mobile robot called Sloth, developed by SoundFounder, which can imitate human to walk. Each leg has two joints, driven by servo. The HCSR04 ultrasonic module works as its height to detect the range and make a turn when encountering an obstacle. The SoundFounder Nano is used as the control board to control the joints and eyes of Sloth. Two 18650 chargeable lithium batteries are to supply the board. Sloth will be a good start for the robot hobbyists to DIY your own robot. Now let's go to enjoy the fun of assembly. So here are all the components included in the package. These are the screws, nuts, and gaskets. This is a set of acrylic plates used for forming the robot body. A servo extension board is convenient for the connecting between the servo SoundFounder Nano board and the ultrasonic module. A SoundFounder Nano board features a main control board based on Arduino Nano, an ultrasonic module for detecting the distance and making a turn when encountering the obstacles. The Tower Pro servo with a weight of 9 grams. A USB cable for downloading the program. A battery holder for holding the 18650 battery. A cable pipe to wrap the servo and the ultrasonic cables. Some ribbon for easy disassembling of the battery. A screwdriver to fasten the screws. An ultrasonic connecting cable to connect the ultrasonic module and the servo control board. Some bypass aluminum standoffs for connecting the fixing plate of the battery and the servo. Some single-pass aluminum standoffs to fix the servo control board. The bed edge bearing for better rotation with little force of friction. The core rivet used for supporting the bearing and it equals to the rotating axis. Before assembling, you need to test the servo and the ultrasonic module according to the following steps. First, please test the servo. Insert the SoundFounder Nano board into the servo extension board. Pay attention, the USB port should be at the same side with the black power socket. Connect the Nano board and the computer via a USB cable. Open the official website of SoundFounder and download the code package. Then add the new pin library accordingly. In the code, the servo is said to be connected to pin 9 of the servo control board. So, connect the servo to pin 9. Pay attention to the wires. The yellow one connects to the signal port, red one to the positive port, and the brown one to the negative port. Then install the rocker arm onto the servo. Choose the right board. And port of the Nano board in IDE. Upload the sketch. You will see the rocker arm rotating within 0 to 180 degrees, which indicates the servo can work. Then the ultrasonic module. Connect the ultrasonic connecting cable to the ultrasonic module. It has an anti-reversing port. Here the 4 pins are marked with labels on the module. Open the program. And connect the pin trig to pin 12 of the servo control board. Echo to pin 11. VCC to the positive pole. And GND to the negative pole. Bird the program to the Nano board. Open the serial monitor. Set the baud rate as 115,200. And hold the ultrasonic module and turn the 2 ultrasonic eyes facing the table or other things close. You will see the distance between the ultrasonic and the table in the window, which indicates the ultrasonic module is good. Next, we are going to assemble the robot. Remove the sticker on the acrylic plates. Before assembling, we define the side with 2 rectangle slots of the battery fixing plate at the robot head, pointing to the front. And when these 4 holes nearly in a vertical line are on your left, you are facing the upside of the plate. Cut the ribbon into 2 pieces nearly equally. And thread them underneath the battery fixing plate. Spare some ribbon at one end so as to take out the battery with the ribbon underneath. You can skip this step if you feel unnecessary. Put a single-pass aluminum standoff onto the upside, the opposite of the ribbon of the battery fixing plate, and fasten them with an M3 nut. Install the rest 3 standoffs in the same way. Fix the bypass standoff under the plate with an M3 screw. Install the rest 3 standoffs in the same way. Fix the battery holder underneath the battery fixing plate. Pay attention that the end without wires should be in the same side with the robot head. Align the holes in the middle of the battery holder and those on the plate. Insert 2 M3x8 screws through the holes and fasten with M3 nuts. Then press the ribbon onto the holder. Align the positive and negative poles of the battery with the holder. Cut the ribbon accordingly. Plug the nano board into the servo control board. Put the servo control board onto the standoffs. Line the holes of them and fasten with M3 screws. Put the servo into the slot of the servo fixing plate and hold it. Then insert the M2 screws from underneath the hole and fasten with an M2 nut. Fasten the other screw. Assemble the other servo in the same way. Pay attention that the shaft of the two servos should be toward the same direction. After assembling the two servos, mount the servo fixing plate onto the battery fixing plate. Align the holes of former with aluminum standoffs on the nutter. Pay attention the servo shaft should be toward the same direction of the two thin slots on the battery fixing plate, which are to fix the head. Then fasten them with M3 screws. Insert the bunches of the lower servo fixing plate into holes of the left foot plate. Put an M3 nut in the holes of the fixing plate. Insert an M3x6 screw into the hole of the foot plate and tighten it. Fix the other lower servo fixing plate onto the right foot plate in the same way. Fix the servo into the lower servo fixing plate. Pay attention the servo shaft should be near the outside of the foot plate, namely the curving edge. Fasten them with M2x8 screws and M2 nuts. Finish both feet. Insert the center bunch of the rocker arm into the hole of the fixing plate. Spin the arm in parallel with the edge of the plate and roughly measure the length of them. Cut off the excess of the arm accordingly and put it back onto the fixing plate. Align the holes on both. And insert two M1.2x4 self-tapping screws. Fix the rocker arm of the other upper servo onto the other fixing plate in the same way. Put the rocker arm of a servo onto the fixing plate. Align the holes and fasten with 2 and 1.2 by 4 self-tapping screws. Fix the rocker arm of the other lower servo onto the other fixing plate in the same way. Insert the bunches of the lower servo into the concaves of the upper servo fixing plate. Keep the rocker arm outward of the lower servo plate. Put an M3 nut into the slot of the lower servo plate. Insert an M3 by 6 screw into the hole of both plates and fasten it. Assemble the other lower servo fixing plate onto the upper servo plate in the same way. So you'll get a bridge-shaped part. Assemble the other bridge in the same way. Make sure the rocker arms are on the outside of the plate. Connect the nano board and the computer with a USB cable. Open the program Simple Robot.ino, go to line 46, and you will see the connection of the servos to the nano. Face the forward orientation of the robot, which means head is at the front. Connect the upper right servo to port 9, the yellow cable to the signal pin, red to the positive pole and brown to the negative pole. Then connect the lower right servo, the upper left one, and the lower left servo to pin 10, 11, and 12, respectively, in the same way. Install the rocker arm onto the servo. In the sketch, go to the line for run and comment out. Activate the line of install, and then upload the program. After downloading, the rotating shaft will rotate to 90 degrees automatically. In the program, the rotating shaft rotates to 90 degrees by default. Remember to unplug the rocker arm. Please note that we install the rocker arm here is just to explain the phenomenon. Put the assembled rocker arm fixing plate onto the upper servo. And fasten them with the built-in self-tapping screws. Try to keep the edge of the two plates parallel with each other. Fix the other upper servo in the same way. Insert the core rivet into the rocker arm fixing plate of the upper servo from the inside. Insert the lower servo into the rocker arm and fasten them with a self-tapping screw. Note that the servo should be nearly perpendicular to the outside rocker arm, which makes saw level on the table. Fix the other foot in the same way. Insert the bearing into its fixing plate and cover the core rivet with the bearing. Insert the bunches of the bearing fixing plate into the holes of the foot plate. Put an M3 nut into the hole of the bearing fixing plate and hold it. Then insert an M3/6 screw into the hole of the foot plate and tighten it. Fix the other bearing fixing plate onto the other foot plate in the same way. Assemble the head. Insert the ultrasonic module into the ultrasonic fixing plate and fasten the module with 4 M1.4/8 screws and nuts. Put an M3 nut into the slot of the ultrasonic fixing plate. Insert an M3/6 screw into the battery fixing plate and fasten them. Open the program and go to line 35. Disable the install and activate the calibration. Then go back to line 11. Adjust the angle of the servo to straighten the robot. Select the correct board and port. Then upload the sketch. If the robot is not set right, change the angle and upload the code until it is. Each time after changing the angle, pick up the robot and you will see the slight change of the robot legs and feet. It may multiple times of calibration. Plug one end of the ultrasonic connecting cable into the ultrasonic module and the other to the servo control board. Connect pin trig of the ultrasonic to pin 13 of the board, echo to pin 3. VCC to VCC. And GND to GND. Go to line 36 again. Disable the calibration line. Activate the operating program Run and burn the program to the board. After burning successfully, unplug the USB cable and connect the power cord to the upper servo control board. You will see the robot moving forward. When encountering an obstacle, it will make a turn and then go forward again. Bind the servo wires and the ultrasonic connecting cable with a cable pipe. So far, the robot has been assembled successfully. It's easy if you follow all steps closely. Hope you enjoy the fun of the bot.